Welcome back everyone. Now that you have the Hyperledger Fabric images and also you have the sample code or the sample fabric samples repositories available in your local machine. Now let us go forward now and we will try to bring up the test network. If you see the folder structure in your fabric sample, test network is the one which we are interested in. So as you can see, this is the test network that I'm talking about. And under test network, you will find different folders. So the entry point for this execution of commands to this folder is in network.sh. So let me open, I have already opened network.sh. So this is the script file which you can see in this location inside test network. So, in this directory, you can find this annotated script, which is network.sh, that stands up a fabric network using the Docker image on your local machine. So, now let us see what are the options or the commands that are available using this network.sh. So I am already inside the test network folder. So I am using the terminal which is available in VS Code itself. If you want to use other terminal, it is totally fine. So since for the convenience sake, I don't want to go back and forth. So that's why I want to show the terminal here itself. So now let me show you what are the options that are available from the script file for you to execute. So type -h and this will give you the help text and which will show you all the modes and also the flags and possible modes and flags that you can give as an input in the terminal, and you can execute these particular commands. So we are going to go to each of these commands and we are going to see what those command does to our network. And let us go inside this and see the content of this script file. So as you can see, you have one function which is print help. So which is what we have seen just now. So print help will give you all the commands that are there, and you have clear containers, you have remove unwanted image, and you have check prerequisite, and you have create organization, you have create create consortium, you have network up, you have create channel, right? And you have deploy chain code, you have network down, and other useful parameters or useful functions that the network's gonna use. So we are going to go one by one with all these functions. So at this point of time, as I explained, these are the possible modes and the flags that you can give. The first one here you can see you can create channel using all these flags. You can deploy channel using all these flags. So in this, now before bringing up the network, so let us clear the network, or for example, what happens in Docker is if you have already some of the Docker containers running, and if you already have some of the materials or the volume mapping that is already running from the previous state, then it might cause a problem in test network. So what you have to do is you have to clear up the network first. So for that, you are going to use a command which is down. So this will stop the network and it will remove all unnecessary images, and it will remove all the containers as well. And this will start you with the execution for with a clean state. So this we will do to start your execution from state 0. So when you execute this command, so this means you are ready, your slate is ready, and you can go ahead and bring the network up. Now let me clear this. Now time to bring up the network. So same same network.sh, This is the script that I'll be using, and I am gonna execute the command up. I'm gonna increase this to show what all the things that are happening. So, as part of this process, which you can see over here, as part of this process, it is generating the certificate using Cryptogen tool. Then it is it is creating organization 1 identity. It is creating organization 2 identity. It is creating orderer organization identity. Then it is generating CCP files for both organization 1 and organization 2, and it is also generating the genesis block using config txgen. And after that, once it is done, the containers are created for peer 1, peer 0 of organization 1 and peer 0 of organization 2, and one more container is created for orderer. So if you can see here, you have 3 containers in the end. Now, Now that we understand this part, now let me clear this and let me execute this command docker ps. So docker ps is a command which will give you all the running or the active containers. So this is not the course where I'll be explaining details about the Docker and Docker Compose file. So please take the course that is available in coding boot camps for Docker learning. So in this course, please remember and go through the commands which are necessary for the Fabric network setup. So Docker PS is one of those commands which will give you all the running containers. So let me go and also tell a little bit theory about this so that you can relate to this, relate the containers and how this container is working, and what is the relationship of the architecture, Fabric architecture that we have seen before, and how that architecture and these containers come together. So each node and user that interacts with the Fabric network needs to belong to an organization. So that organization should be the network member. The group of organizations that are members of Fabric network are often referred to as a consortium. So the test network has two consortium member, which is organization 1 and organization 2. So which you can see here. So you have organization 1 and organization 2, and this forms a consortium. So the network also has one more orderer organization that maintains orderer service of the network. So this is the orderer container, or so this container or this peer is maintained by one more organization. So peers are fundamental components of any Fabric network. Peers store the blockchain ledger and validate transaction before they are committed to the ledger. Peers run the smart contract that contains the business logic that is used to manage the assets on blockchain ledger. Every peer in the network needs to belong to a member of the consortium. So in the test network, each organization operates one peer, which is organization 1 operates peer 0 of peer 0 org1.example.com, and organization 2 operates peer0.org.example.com. So every Fabric network also includes an ordering service, which I've shown here. So while peers validate transaction and add blocks to transaction to add blocks of transaction to the blockchain ledger, they do not decide on the order of transaction or include them in new web. So on a distributed network, peers may be running far away from each other and not have a common view of when a transaction was created. So coming to consensus on the order of transactions is a costly process that would create overhead for the peers. So an ordering service allows peers to focus on validating transaction and committing them to the ledger. So after ordering node receives endorsed transactions from clients, they come to a consensus on the order of transactions and then add them to the block. The blocks are then distributed to peers, which adds the blocks to the blockchain ledger. So ordering nodes also operate the system channel that defines the capability of a fabric network, such as how blocks are made and which version of the fabric that the node use, and the system channel defines which organization are members of the consortium. So here in this test channel, we will be using raft ordering service, and that raft ordering service will be running inside this example.com. Now let us look into the logs and see if you have any error inside this container. So the command that is used for this is docker logs, and you are going to take the container ID and you are going to paste it here. So as you can see, if you see any error in this, that means there is something wrong that you have done. So if you see blue and white, then your orderer is working properly. So you should be able to see all these logs. Same way for peers as well. So let me go and take the container ID of one more peer and execute this. So as you can see, it is running fine. So there are no errors. So this means your container is up. Two containers belongs to each one of them belongs to one organization, meaning as we have seen here. So we have ps0.org1.example.com belongs to organization 1, and we have ps0.org2.example.com belongs to another organization, which is organization 2, and we have orderer, which belongs to one more organization. So until this point, we have brought up the network, which contains three containers. So three containers represents different entities in the fabric network, and those entities or the peers belongs to different organization. So that is it for this lecture, and we will continue in the next lecture. Please follow this and please execute the commands in the same sequence that I am executing, and we will see you in the next section.